All right, here we are again, continuing on with our exponent rules. Okay, so there's two more. Number 5, hang in there. Number 5 is called change of base. This is not very common on the SAT, but it does pop up a few times, so I just want to quickly review it. And that would be something like this, where let's say I had, say you had this problem, 5 cubed times 6 squared. Okay, I'm just saying, this is not an SAT question. I just want to emphasize something. Well, like we talked about with the first rule, with multiplication, right? We can only add the exponents when we're multiplying if the bases are the same, but they're not. So really, we just kind of have to leave that go. The answer is just, well, whatever that is times whatever that is. But there are cases when you have numbers that have different bases, but it's relatively easy to change one base into another. And then that means we have the same base and we can just add up the exponents. Let me give you an example. Supposing I had something like this. Supposing I had 2 cubed times 4 squared. Now, I know you could use a calculator and figure out what this is, but supposing this was the non-calc section, just bear with me for a moment. Probably could use it even without a calculator, but just I'm sorry, I'm babbling. The bases are not the same, right? So we have a 2 and a 4. We can't just add the exponents. But if you notice something, first thing you always do is you just put a parenthesis around the numbers. That kind of helps you keep things straight. Just trust me on this. All right, so it's just 2 cubed and then 4 squared. But notice something here. 4 is just the same thing as 2 times 2, right? That's 4. Well, 2 times 2 is, we could write that in exponent shorthand as just, that's 2 squared, right? So this whole inside part right here, this 4, we could rewrite it as 2 squared. And I'm going to do that. Let's do it in blue. Okay, so this part, it's 2 cubed times, okay, 4, but 4 is just that, so I was just going to say 4 is just the same thing as 2 squared, and then that is squared. Okay, well now we've done something here. We've made the bases the same. Instead of having a 4 and a 2, now we have a 2 and a 2, which means we could use this rule here, the multiplication rule, where we add the exponents. But we also are going to have to use rule number 3, because notice we have a parenthesis issue here. We have a number inside with an exponent, another exponent on the outside. And the way that we deal with that is we multiply, right? We would just do 2 times that 2. So this whole thing in the blue boils down to this. 2 cubed times 2 to the 4th power. And then finally, last step we can do is we can just add those exponents because the bases are the same. So it's 3 plus 4 is just 2 to the 7th would be the answer. Okay? Change of base is, again, a little bit unusual on the SAT, but it may come up. So you want to be comfortable with this. I will say the only numbers that I've ever seen they expect you to do your change of base with would be 2 and 3, and maybe sometimes a 10. So here, like for example, so it'd just be these numbers. It would be 2, 3, and 10. And all you'd have to do is just remember what the sort of the multiples or exponent changes for 2, 3, and 10 are. So for example, 2, 4, 8, 16, 32, 64, so on, right? That's 4 is just 2 squared, 8 is just 2 cubed, 16 is 2 to the 4th, and so on and so forth. And the same thing goes with the 3, right? So the next one would be 9, 27, 81. I can't do mental calculations beyond that, but yeah, so that would be 9 is just the same thing as 3 squared, right? Because 3 times 3 is 9. 27 is the same thing as 3 cubed, because 3 times 3 times 3 is 27, and and so forth. Okay? And then likewise with 10, what would it be? 100, 1,000, 10,000, right? 100 is just 10 squared, 1,000 is 10 cubed, and so on. Okay? So we will practice. I'm going to do an illustration of a problem that's involving change of base, but that's really all that you have to do. Is you're going to want to change the bigger numbers into a form of the smallest one. So for example, if I had, here, let me just do one more quick example, because I feel like I hear myself speaking, and it doesn't make sense to me, so I can only imagine what it's like on your end. But here, so change of base, like here, let's do one quick example here. Supposing I had, let's say 3 cubed, oh, that's a terrible looking cube there. 1 second. Here we go. 3 cubed times, how about 27 to the 4th power? And they'd ask, what would this be? Again, if you had a calculator, you just plug this in and get the answer, but this is usually going to be a non-calc question. So 3 cubed, well, that's, here, step 1 you'd always be, is you always try to see if you can convert the bigger number, which in this case would be the 27, into the base of the smallest one. And the clue is that we have a 3, right? So we know that it's probably going to be the case. Let's think about this. 27. That's just the same thing as 3 times 3 times 3, right? Well, and that in exponent form is just 3 cubed. So we just pop that in there. Oh, sorry, I messed up there. It's supposed to be 4. Hold on. There we go. Get that out of the way. Cut it. Let's see here. Let's put that 4. There we go. Oh. Okay, here it is. I'm channeling my inner Bob Ross. Yeah, we're just gonna slap a little purple over there. Anyway, okay, sorry about that. So that would mean, so then instead of writing 27, we could just say, well, that's just the same thing as 3 cubed. So now the bases are the same, which means we're going to be able to use our first rule, right? We can add the exponents, but we also have to do the parenthesis rule here because we have this 4 hanging outside and the 3 on the inside. So that gets us to 3 cubed times 3 to the 12th, right? 4 times 3 is 12. And that is, well, base is the same. We just add them. The whole thing would become 3 to the 15th power. Okay. That's it for that one. Last rule. I know this video is running a little long. Last rule here. I promise this is it. And that is going to be rule number 6, the radical rule. We call it the radical / square root rule. Square root rule. And that would be something like this. Anytime you have a square root symbol and something inside, let's say x, okay, that can be written as an exponent. The root sign really just means it's going to be written as a fraction. The exponent is a fraction. In this case, since we're taking the square root, right, we need to find 2 numbers that would multiply out to make whatever x is. We write as a fraction with 1 over 2. If I had, say, this, if I had, say, a quad root, or, 4th root, whatever, and say x, well, that's just written like this. And so on and so forth. Whatever that number is on the outside. So when you have just the square root, they don't write it, but the number really is 2, right? We're trying to find 2 numbers that would multiply to make this. But whatever the number is, you just apply it as a fraction to each term inside. It's really kind of a form of the parenthesis rule, really, if you think about it. So the way you could do it is you can think about it like this. Supposing I had, let's say I was supposed to do the 5th root, and I have x to the 5th, y to the 3rd, and z inside. Well, the way that you'd handle it is you just simply write the radical, this root sign, as a parenthesis, put all the terms inside, so we have x to the 5th, y to the 3rd, and z. Okay? And then this 5, we know because it's a radical sign, we know it means that the exponent for these terms is just supposed to be 1/5. So we just put 1/5 out there. Okay? And now that we've converted it into that form, we can use our parenthesis rule, right? We just simply multiply each exponent on the inside of the parenthesis by the outside one. So that would just get us to this. Let's see, clear a little space here. Got this. Let's change the color of cigarette. Let's do sky blue. All right. So that would be x to the 5th times that exponent's times 1/5, and then we'd have y to the 3rd power, that times 1/5, and z, even though it's not written, it would be z to the 1, right? Times 1/5. And then we'd simplify this. Well, 5 times 1/5, that's just 1. So that's just x. 3 times 1/5, that's 3/5. So we just write that down. And then z, 1 times 1/5, well, that's just 1/5. And there we have it. Don't get freaked out if you've got fractions for exponents. It's fine. Just use the steps here. You just recognize that, okay, if you have a radical sign and some sort of number on the outside, well, it really just means it's a parenthesis rule, but you're going to be multiplying every exponent by whatever that say if it's a 5, then it's going to be 1/5. If it was a 4 out there, it'd be 1/4. Whatever the number is, slap a 1 on top of it, and then go from there. All right, this video is running really long. That's it for that. Godspeed.